Welcome back to Dave Does Math from Home. This is part two. Ow. This is part two of our video series on trig integrals, which is a poorly named version of a section that should be called integrals of trig functions embedded compounded into power functions. We're just going to go straight into some examples. So we did all our theory crafting in part one of this video. So what we have here is an integral of some trig functions embedded in compounded functions with power functions. So we know how to take derivatives, or integrals of that. As I said in the other video, the goal is to transform sines and cosines into the other piece in pairs until there is exactly one copy of one of them. I don't care which one it is, but we have to be left with exactly one sine function or one cosine function so that we can use that as the other in integration by substitution. And because we transform these things in pairs, we pretty much have to always choose whatever has an odd exponent. That's the one we have to go with. So if we transform this cosine squared into 1 minus sine squared, we can transform this into nothing but sines, and that doesn't help us because we need to have exactly one cosine in there to do the integral with sines so that that cosine can be our other. So that's not going to help us. We're going to have to use this one. And it's going to turn into a little bit of a mess because we have to do this transformation twice. So we'll just get right into that. First I'm going to write this as sine of x times sine squared x times sine squared x times cosine squared x dx. So my cosine squared hasn't changed. My sine to the fifth has become sine, sine squared, and sine squared. This is my one copy that is going to stay by itself alone as the other function. These need to turn into cosines. So that's going to look like sine squared x. This is 1 minus cosine squared x. This is 1 minus cosine squared x. And this is still cosine squared x. I hope everyone remembers how to FOIL, because it's time to do some FOIL. The sine is the thing that I am not going to FOIL. I want this to stay separate. I'm going to FOIL these things. So that's going to be 1 minus 2 cosine squared x's plus cosine to the fourth x. So first, the inside and the outside piece will each give me one of these, so there's 2, and the last will give me a positive cosine of the fourth. And I still have my cosine squared on the back end. Got my dx. So I'm going to distribute this in here so that I can consolidate all of my cosines. Still going to leave this separate. This is sine of x times, big brackets, cosine squared minus 2 cosine to the fourth plus cosine to the sixth dx. So there's a fair bit of algebra going on here. So far we haven't actually done any calculus. We've just taken this weird trig expression and transformed it into a different weird trig expression using algebra and Pythagorean identities and lots of foiling and distributing. This has all been algebra so far. But all of this algebra has made it possible for us to now do the calculus and evaluate this integral. Once again, I'm going to erase most of this, so pause the video if you're still writing. There we go. Okay, so looking at this, I erased a little too much maybe. We need an inside. I should have erased this as well. That's fine. I need an inside and an outside and an other. The other is definitely going to be the sin x dx by design. That was our goal the whole time. That's why we did all this algebra. If we want the other and the inside to match in terms of derivatives, we need to make this into the cosine of x, which means that the outside is all of the things that are happening to all of these cosines. So in the first video I mentioned double blobbing it. Here we're going to have to triple blob it, because we have 3 cosines here, and that's the inside function. So the outside is going to have 3 blobs. Looks like it's going to be a blob squared here, minus 2 blobs to the 4th, plus blob to the 6th. And then we set w equal to this cosine, and dw then is negative sine of x dx. So I need to put a negative sign here, and then I'll put one on the outside for balance. So now that these things match, so now I can do a substitution. This is the integral, sorry, this is negative integral. The negative sine x dx, that's all just dw. This is w squared minus 2w to the 4th plus w to the 6th. And there's my dw. This is a very easy integral. It's negative w cubed over 3 plus 2/5 w to the 5th minus, I'm trying to distribute this negative sign while I also do the integral. Maybe I should have done that in 2 steps. Too late now, I'm committed. Minus 1/7 w to the 7th plus c. Negative third, positive 2/5, negative 1/7. Yes, okay. I've convinced myself that I haven't made a mistake yet. If you ever do catch me making a mistake, please leave a comment. I'll fix it. So I just need to unsubstitute now for cosines. So this is negative 1/3 cosine cubed x plus 2/5 cosine to the 5th x minus 1/7 cosine to the 7th x plus c. That is the result of this entire process, which was 60% algebra and then 40% calculus, I think. It's hard to tell with some of these. We're only 8 minutes in. Time for another example. This technique can also be used to integrate things that just look like this. This is just a sine cubed. There's no cosines anywhere in sight, but we can introduce the cosines if we change this to a sine x times a sine squared x dx, and then we swap out the sine squared for 1 minus cosine. Sine x times 1 minus cosine x, 1 minus cosine squared, I mean. For this one, you do kind of want to distribute the sign to both pieces, because this is not really a double blob technique. Like for the last 2 examples, we've left the sign separate because the entire inside we've been able to double blob or triple blob and just take care of it all at once. But this isn't the double blob technique, because one of these things is a cosine and one of them is just a constant. So this is the case where you'd want to distribute the sign into here. So you have the sine of x minus sine x cosine squared x dx. And then you could split this into two integrals. This one we know. This is very straightforward. This negative cosine x minus whatever this is. This looks like it's just going to be a really straightforward substitution. So if I'm substituting a cosine, that means I need this to be negative, and it'll be positive here. And then this will just be cosine cubed over 3 plus c. So you can use this technique to do integrals of trig functions to powers, to odd. It only works with odd powers. You can do this with odd powers here, and then you have you introduce the other piece that way. So this question, or this technique I should say, lets you handle one trig function to an odd power multiplied by another trig function to any power at all. You only need one of them to have an odd exponent for this to work. So then the question becomes, what if they both have an even exponent? And that is a great question. That's what we're going to do right now. A couple sections ago, we talked about the half angle formula. We said if you have sine squared x dx, you can use the half angle formula to transform that into 1 minus the cosine of 2x over 2. And if you have the integral of cosine squared x dx, you can use the half angle formula to turn that into 1 plus cosine 2x over 2 dx. These are the half angle formulas. We finished these in an earlier video. I'm not going to spend time doing them again. What I do want to spend time doing is, I want to talk about what happens when these things are multiplied by other things. Because that's when it gets real interesting. So we know how to integrate sine squared. We know how to integrate cosine squared. That's pretty straightforward. What happens if we try to integrate sine squared times cosine squared dx? This is the very interesting question. And some of you might be thinking, oh, well, couldn't you just use the half angle formula on each of those things and then FOIL it? And the answer is yes. And I'm going to do that because it gets really horrifyingly messy. Let's get started. This one, 1 minus the cosine of 2x over 2. This one's 1 plus the cosine of 2x over 2. I'm going to do, the next step I write down is going to be a substantial leap in terms of all the different things that are changing. So I want to talk about it a little bit. First thing I'm going to do is I'm going to take this over 2 and I'm going to take this over 2 and I'm going to get rid of both of them. I'm going to put a 1/4 on the outside because coefficients are safe and I'm allowed to do that. The other thing I'm going to do is I should be foiling these things. 1 minus cosine of 2x and 1 plus cosine of 2x. That is the product of two binomials. So I should be doing FOIL, first, outside, inside, last. This should end up being 4 pieces. But I'm going to look at it closely and I'm going to see that this is a plus b and a minus b. We call those things conjugates. That's going to give me a difference of squares situation. So I'm going to skip most of these FOIL-y steps. I know what's going to happen when I do this is I'm going to get 1 minus, I'll get the product of the first ones minus the product of the second ones. So 1 minus the cosine squared of 2x. just got rid of our cosine squareds, and now there's another cosine squared. Yep, time to do it again. I'm going to split the integral, actually. I think that makes it easier. 1/4 times the integral of this is just x over 4 minus the integral. Yeah, that part's done. I don't want to deal with that anymore. I just want to deal with this cosine business. I'm going to split this cosine using the half angle formula. I'm going to call this 1 plus the cosine squared. It's twice whatever this is, so I'm going to call it 4x. Oh, I have to distribute this 1/4 as well. I'm going to be splitting the integral into two pieces. So we still have the 1/4 on the outside. Now I have 1 plus, it's not cosine squared, 1 plus the cosine of 4x over 2 dx. I'm making all kinds of mistakes. This is what I mean, it gets messy. So, this part's done. I'm going to pull the 2 out. So this will be x over 4 minus 1/8 the integral 1 plus cosine 4x dx. Which took some getting to, but now that we're there, it's pretty doable. I'm going to see if I can squeeze it in over here. Still have the x over 4, that part's not going anywhere. I'll do minus 1/8 and then start a big bracket. The integral of 1 is just x. The integral of cosine is sine of 4x. But because of that linear substitution, I need to divide by 4. And that'll add a c at the end. So, all told, when we simplify this out, we have x over 4 minus x over 8. I can probably simplify that a little bit more, huh? So, x over 4 minus x over 8 plus the sine of 4x over 32 plus c. And then these guys, you can combine those into x over 8. X over 8 plus the sine of 4x over 32. Yeah, we got there. Plus c. Yeah. That'll do it for me and trig integrals. Yeah, some of these get messy, but keep your algebra really tight and focused. Go slow, take your time. Don't make any of the mistakes that I made while doing this. Good luck.